Okay, now we're going to talk about the inverse of the rational graph, and we're going to have to be a little bit careful. The last video, I showed you that the inverse of the inverse graph is the inverse graph. And how you could, I didn't show you graphically. So notice that the original inverse graph, when you put a diagonal line, 45-degree angle through that graph, this side and this side would fold up on each other if you were to fold that over the diagonal, and same with down here. So graphically, that's how they are inverses of each other. Now, if you look at the rational graph on the right side and you put in that diagonal line, notice this right here and this right here would not fold up. This is curving at a very fast pace. This is not as close to the y-axis as this is close. So this right here is not its own inverse, and I wanted you to see that graphically, and now we're going to do it algebraically. So when we find the inverse, this is what it's going to look like for the rational graph, but let's show you algebraically. So if you have y is equal to x squared, you're going to swap 1 over x squared, excuse me. You're going to swap the x's and the y's. And then again, you're going to put that invisible 1 there. You're going to flip both sides. So you now have 1 over x is equal to y squared. And when you take the square root of both sides, well, the square root of 1 is just 1. And then you have the square root of x. But remember, you can't take the square root of a number less than 0. However, because this square root is in the denominator, you also can't take the square root of 0. So the rational graph has a restricted domain. So the only part we can look at are for all the x values greater than 0. And when you type that into Desmos, y is equal to 1 over x squared, or y is equal to 1 over the square root of x. This is the graph that you're going to get, and graphically you can see how they indeed are inverses of each other. All right, that's it for this one.